Welcome everyone. In today's session, we're going to cover the latest developments of ANSA version 23. The enhancements in version 23 are mainly in the areas of graphics, modular run management, geometry, meshing, topo and mesh unified, and then to assembly, durability, composites, crash and safety, kinetics and NVH, CFD, electrochemistry, electromagnetics, electronic CAD, morphing and optimization, virtual reality and augmented reality, machine learning integration, and finally, user productivity. We're going to start off with the graphics. There's an up to 7-time improvement in terms of graphic performance and up to 50% acceleration of model navigation. Regarding the modular run management, ANSA version 23 offers support for relative path references within include files, also for file-based DMs. The functionality is controlled through a setting in the data model configuration file and is only applicable to the new DMs. A new view type has been added for subsystems in the DM browser that presents the lifecycle of subsystems in a list. In previous ANSA versions, lifecycle relationships were displayed in the References tab and in the lifecycle graph. Now the lifecycle list view mode comes as a list alternative of the lifecycle graph view. A new function labeled Show Changelog is available on single selected items, offering a cumulated presentation of the difference between the selected object and its parent. This new function is equivalent to running Compare Containers by selecting the DM object of interest and its immediate parent. In addition, a new bottom tab in the Compare Containers view displays the complete change set history between the selected differences. Lifecycle management of CAE data is now supported for SPDRM and file-based DMs. A set of rules that govern the evolution of a DM object can be specified for all available data types. These rules are enforced while working with a DM that has lifecycle management activated. Among others, through the lifecycle business rules, it's possible to control accepted transitions of property or attribute values, conflict resolution policy and versioning scheme based on the DM object status and other characteristics, and maturity of DM objects based on the maturity of its references and contents. Regarding geometry, it is now possible to automatically create faces or FE with a real-time preview and direct modifications. Geometrical mapping and diffing for 2D holes and stamps is now possible for the Compare tool. Potential differences on feature level are highlighted by the new Draw mode. Regarding meshing, on the casting side, direct mesh copy of similar areas and automatic connection to the new middle meshed ones are now available. Special features can be handled with automatic removal and mesh fixing. Fillets are now more accurately captured with respect to geometry and thickness during automatic middle mesh generation. An automatic identification of areas which are suitable for casting inherent functionality is now possible. Automatic identification and fixing of cracks and gaps is now available on FE models. Moving on to something which is completely new and is probably one of the most groundbreaking implementations of version 23, the unified topo and mesh. A complete manipulation of geometry and mesh from one toolset is now possible. Some examples include the topo cleanup, the skin creation, the mesh generation, and the FE manipulation. Modern neat design in a common GUI unifies the functions which work for both geometry and FE. Special toolsets are now available, including the whole functionality a designer or an analyst may need. Direct geometry and mesh manipulation lies now under one function. Different options are available based on the selected draw mode. so there is no need for the user to change the menu or to exit the direct edit functionality during a process, since the various functionalities are accessible via the context menus depending on the selected entity. New developments have been also introduced in the assembly field as well as the connection manager. Automatic generation of pretension and contacts through bolt-on solid is available in the connection manager, followed by the definition of appropriate steps and loading conditions for Abacus, ANSYS, Nastran NX, and PAMcrash. Moving on to the disciplines and starting with durability. Stress results are now plotted for the calculation of the cross-sectional properties of non-homogeneous solid cross-sections through the FE and FE2D cross-solvers. The FE and FE2D cross-section solver can now solve mixed thin solid cross-sections. A dedicated environment to transfer model data results and material state between Abacus analysis is now available. In the illustrated example, a deep drawing simulation is performed with Abacus Explicit. The deformed shape is extracted from the last state of the analysis and is used as the initial state of a new analysis. The import keyword is used to transfer the stress state of the deformed geometry to the new analysis, and a spring-back simulation is then performed with the Abacus standard. The Result Mapper tool is now able to map initial stresses and initial plastic strains results in the MARC deck in a table-driven format style. The supported deck results are for Nastran, LS-DYNA, PAMstamp, Abacus, and Radius, and the mapping can be applied to both shells and solids. After the mapping process, the appropriate solver entities are created according to each deck. The Contact Parameters window in MARC is redesigned to be more user-friendly with more comprehensible terminology. In addition, these changes are also applied in the Hidden Edit card in order to enable the user to utilize the new labels from a script. Several enhancements in the MARC Load Case Setup Assistant in the MARC deck have been implemented. First, the analysis options appear according to the selected type of the analysis. In addition, there's also an easy setup of automatic large strain formulation using pull-down menus, considering the material types. And finally, a redesign of the Load Case Options card with mutually exclusive fields and a more user-friendly terminology. A stepwise assistant for the automatic creation of all possible pretensions for the MARC solver, including the generation of the respective keywords, the definition of the appropriate load cases, and the functionality generate the appropriate contacts around bolts, is now available. Regarding the improvements of the inverse forming tool. The tool is now able to calculate and display stress results from an inverse forming analysis, and furthermore, the users can output all the FLD points and the respective curves in a spreadsheet format. In the Composites field, the Laminate Tool UI layout has been improved, aiming to unclutter the screen space. The property attributes that are not related to laminate layers have been removed. A side panel has been added to contain all layer attributes. This was done in order to unclutter the layers list by hiding the uncommon attributes and still have them accessible when needed. The visualization settings and sorting arrows have been relocated to reduce the overall window size, and the side panel can be switched off in order to leave visible only the most commonly used layer attributes. Moving on to the crash and safety discipline. The HBM articulation tool now supports all the latest updates in the GHBMC, Thumbs, and Viva Plus families models for LS-DYNA, PAMcrash, and Radius solvers. A complete solution for setting up an HBM Cyclist load case is now offered using the new Bicycle Configurator tool combined with the already existing HBM Positioner. The new Configurator tool allows to adjust the bicycle dimensions according to the HBM size model or any custom dimensions. The seat belts can now be efficiently passed through complex geometries using the new Direct tool with local modifications of the shape of the belt. In the video, a case which is considered difficult is illustrated on a child seat with a seat belt passing through. In the pedestrian tool, the GBT 24550 Chinese regulation, the JNCAP 2019, and the China Insurance Automotive Safety Index protocol are now supported. A new interface is now available in order to create separate lines instead of the complex protocol marking, and this is also possible through scripting. A new function in order to modify the initial trace of the bonnet rear reference line and reapply the intersections with a semicircular template is now added. Last but not least, the performance of the positioning functions in terms of time has been improved. In the IP Impact tool, a new positioning method is now supported, the normal to line, according to the SAE recommended practice. Moreover, setting up a custom steering wheel is now supported by the tool. In the FMVSS 226 tool, new improvements are now implemented during the marking process. First of all, a report is now created containing the exact steps of the marking, along with images of the model for each step. 3D points are now created on the geometric centers of the glazings. All auxiliary entities are now named according to the regulation, and user-defined daylight opening curves can now be given to be used in the marking process. A bus rollover analysis can now be officially set up for the ECR 66 and AIS 31 regulations using the new dedicated tool offering integrated kinetic solutions. Regarding the isogeometric analysis, a new dedicated toolset, the IGA, is now available for the manipulation of the IGA-related functionality. New IGA LS-DYNA keywords are supported. The algorithm for IGA creation is improved in terms of interface accuracy between adjacent patches. And last but not least, the displayed IGA shell information is now enhanced and also identifies negative Jacobian areas. Plugins for crash and safety have a new place under the analysis tools. For example, the HPM pre-simulation plugin can now be found under the corresponding group of functions. Other plugins, such as the low speed, have a new dedicated button, while the plugins used for the FMVSS 201U regulation can now be found under the interactive 201U tool. All PAM crash keywords for VPS version 2021 are now supported. In regards to the kinetics, there's often the need to perform an optimization analysis in order to find the best combination of parameters on mechanisms with the goal to improve the overall performance that will meet the specified requirements. Kinetics now include an optimizer that is using the IPOPT library. The optimizer is based on the sequential approximate optimization methods in order to improve efficiency, especially on large-scale models. Design constraints can be handled as dual inequality equations, which is quite convenient since the user can optionally specify lower and upper allowed values for them. Additionally, discrete optimization is also supported when design variables are defined through a set of discrete values. Regarding the NVH, there's a seamless setup of optimization variables, responses, and objectives in the answer optimization tool within the NVH console. The Monte Carlo algorithm for DOE status is available, as well as a simulated annealing algorithm again for optimization studies. The solutions for CFD include the batch mesh enhancements with an up to 50% time reduction in CFD mixed type meshing, and improvements in robustness and quality of anisotropic meshing at leading edges. Version 23 of ANSA allows users to mesh thin areas of volumes using Prism, Hexa, and polyhedral elements. The functionality is activated within the Thin Area Treatment option in the Layers window. It automatically identifies regions in proximity and fills them with layers, providing a result similar to, for example, the mapped mesh. This is ideal for meshing thin regions or sheet metal parts, for example for conjugate heat transfer applications. The Leak tool has been enhanced. The function identifies any leaks at the interior of the model, and apart from creating patches to close the leaks, it also creates a draft wrap for internal volumes in order to avoid further leaks to the model interior. In the field of electrochemistry, The couple's thermal electrochemical analysis type is now supported along with all the necessary keywords to specify the initial conditions and parameters of a battery model in order to simulate its electrochemical behavior. Particularly, this option can be used to analyze problems where temperature, electric potentials of fluid and solid, as well as ion concentration fields need to be solved simultaneously. Regarding the solution for electromagnetics, the Acerus pre-processing interface enables the creation of complete ready-to-run simulations. There's an easy boundary condition setup, a material library setup, there are various analytical illumination sources available, a cable surface junction detection, and finally single-click lambda voltage impedance setup. On the ECAD side, through UNSA, the user can go through a dynamic component selection, customizable base mesh, preserving the shape of included components footprint, a uniform structured mesh with property assignment per element, and finally a visualization of metal volume fraction per element via custom fringe bar and mesh discretization error calculation. Regarding the morphing discipline and the optimization domain, a new tool has been added in version 23 that facilitates a generation of new reinforcement parts over one or multiple regions. The user can select the regions over which the reinforcement will be created and can provide either predefined curves of the new part's shape or draw on the spot its outline. Then the new regions can be fused, according to a user-defined angle, and create automatically the new part. Morph parameters can now be previewed one by one or as a combination, allowing the users to investigate multiple designs of their model. The order of the running parameters can be modified, and different values can be applied directly on the new interface of the Morph Preview tool. Moreover, the creative designs can be saved as UNSA files in order to be investigated in more detail. This tool can be accessed from the context menu of the parameters list. A new mode has been added in the bend movement of the form function. Up to version 22, only the ends of a selected region could be bent. Now, in version 23, the pin ends mode is added in order to facilitate pinned ends bending. The PM extrude and sweep functions have been enhanced with more functions. Users can now elongate existing members towards a specific direction or create new members from a single profile consisting either from geometry faces or pure FE shells. Moreover, existing members can be elongated according to a given path. Geometry morph with boxes can be done directly, rapidly and accurately without intermediate steps. Until now, the geometry check was needed, but in version 23 it is obsolete, making the morphing easier and faster. The feature creating tool can now be applied directly on geometry. There is no need for FE mesh, and at the same time, feature end caps are now displayed in a separate field, and some new ones are supported, providing wider variety and higher accuracy in feature creating options. Up to version 23, beads could be created only as features with rounded and sharp closed end. Now in version 23, features with slope and open ends were added to this feature type. The feature copy function of design change has been enhanced with some copy patterns. Array, circular, and follow path are the new pattern types that have been added in order to facilitate the process. The user can select between them and create copies in the desired pattern massively in one step. The feature scale works now as a separate function independently, providing the opportunity to scale a feature along a specified direction with more detail and immediacy. Now moving on to the optimization domain. The option for a new user-defined DOE is also available in UNSA version 23. A new DOE table can be created consisting of a set of experiments. Having already a DOE run, the desired experiments can be copied and pasted on the new one. In this way, the user can have its own defined DOE adapted to their needs. The Kriging algorithm is added as a response surface method optimization tool. It can be created using an existing DOE and can be used in collaboration with an optimizer for faster optimization studies locally or in DM. The optimization studies based on either Kriging or simulated annealing direct algorithms can now run locally without the need of connecting to a DM. Number of parallel jobs can now be defined for DOE runs. The experiments are distributed to the respective number of jobs, where the respective ANSA batch mode applications run in order to perform the DOE faster. New chart types are added in the optimization tool results. The correlation matrix shows the linear relation between the two variables. A value of 1 means that the variables are positively correlated. 0 means that there's no correlation, and -1 means they are negatively correlated. The main effect plot represents a response mean for each factual level connected by a line. Steeper slope of the line means greater main effect, while horizontal line means no main effect. The interaction effect plot presents how the relation between response and a factor depends on the value of a second factor or moderator. Regarding virtual reality enhancements in version 23, images can be saved of what can be seen through the headset or by utilizing the virtual reality menu as a camera. Moreover, the field of view can be adjusted and images can be saved of various aspect ratios. To-do lists can be created and handled in virtual reality and virtual reality collaboration. Each to-do item can have its own notes, images, recordings, or positions with respect to the model facilitating task assignment within the team. Another field with some dedicated tools that have come to life quite recently is the machine learning integration field. Seamless cooperation of machine learning identification with inheritance of the mesh from previous models during the generation of the middle mesh is available, as well as automatic connection of embedded CLIPS FE representations which are stored in the DM with the underlying parts through the feature manager and casting. An example regarding the feature detection is now illustrated. In the field of user productivity, direct job submission is now available through the analysis tools Run Command for the Abacus, LS-DYNA, and PAM CrashedX. Monitoring of the job execution as well as error handling is also available while the solution is still in progress. A new tool is now available in order to create and handle lists of to-do items along with auxiliary notes, snapshots, location in the model, audio clips, and sketches. The drawing of connection points has been enhanced in version 23 as illustrated in the video. Specifically, connections remain visible even during zoom in or zoom out actions as shown. The database browser has been completely restructured per category. This means that different entities fall under specific categories. In addition, the user is also able to select entities of multiple types. A whole stripe of entities or multiple entities of the same type can now be selected on a single action for direct edit, since access to the feature selection menu is accessible. Furthermore, a preview of the deselected entities is now also provided. An alternative method in order to deselect entities by using the Shift button, along with the left mouse button, is now available, providing also a preview to the user. Finally, CAD PMI annotations can now be imported or exported via JT file as ANSA notation entities or ANSA curves. This concludes the What's New presentation regarding the latest developments for ANSA version 23. Thank you for your attention.